So today, we have an interesting geometrical problem. The diagram is on the screen. So the diagram is formed in this particular manner. We have taken a triangle ABC. Now for this triangle ABC, we have drawn a circle so that the circle is tangent to one side of the triangle at the point Q. Now there can be many possible ways in which a circle is tangent to a triangle in this particular manner. So to limit all these possibilities, we have given a situation, and the situation is like this way. When we have drawn a circle so that it is tangent to one side of the triangle, it is ultimately meeting the other two sides of the triangle. So let that intersection point be labeled as P and R. Now the situation is like this way. Out of all the possibilities, you have to take the only possible case when you will draw a quadrilateral joining the points P, Q, R, B, and that quadrilateral will form a parallelogram. So this is how the diagram was constructed. Now it has been given that the area of this purple triangle is 1 meter square, the area of the blue quadrilateral that is ultimately a parallelogram is 4 meters square. So using the areas of these two figures and the way we have constructed this diagram, you have to find the area of this red triangle. So this is Anmol, and now let us see the solution. How can we find the area of red triangle? Okay, now let us start with the solution. So the first thing that we are going to do is we are going to utilize the fact that we have a parallelogram inside this diagram. Now what exactly is a parallelogram? So parallelogram is a quadrilateral in which opposite sides are equal and parallel. Suppose I take this a quadrilateral. Now if this quadrilateral is a parallelogram, this means the opposite sides are parallel to each other and also they have the same length. So these two will make a pair because they are opposite to each other. Similarly, these two sides are equal to each other and they are parallel to each other. So now as in this particular diagram, we can see that the quadrilateral PQRB is a parallelogram. So the quadrilateral is this blue quadrilateral. Now as it is a parallelogram, these two sides would be equal and these two sides would be equal. So let us write it down. So the length of PB would be equals to the length of QR and let it be equals to a variable X. Similarly, the length of PQ would be equals to the length of BR and let it be equals to a variable Y. Okay. Now this was the first thing that we marked, that is they are equal. Now we have one more thing, and that is the opposite sides are also parallel to each other. This means PB would be parallel to QR and similarly PQ would be parallel to BR. Okay. As the quadrilateral PQRB was a parallelogram, opposite sides become parallel and also equal. Now look carefully in the diagram. So as per the construction of this diagram, the point P lies on the line segment AB. So if PB is parallel to QR and P lies on the line segment AB, this implies the complete line AB is also parallel to QR. So we can write PB is parallel to QR. This implies AB is also parallel to QR. Now similarly, the other case, that is PQ is parallel to BR. Now the point R lies on the complete line segment BC. So if PQ is parallel to BR, this implies PQ is also parallel to BC, and these two cases are happening because of the construction of this diagram, in which it was clearly mentioned that the point P and the point R lies on the line segment AB and BC. Okay, so let me just mark these things in the diagram. That is, the complete line AB is parallel to QR and the complete line BC is parallel to PQ. Okay. Now as we have parallel lines inside this diagram, this means we can use the properties of parallel lines. So there are basically three properties and they are like this way. If there are two lines that are parallel to each other and there is one more line that is joining them both, this line is basically called the transversal. And let this line be as the line L and this line be the line M. So here it is already given that L is parallel to M. Now if there is a line that is cutting two parallel lines, then there are three cases of the angles and they are like this way. These two angles are always equal to each other and this property is called the corresponding angles. This particular angle would be equals to this particular angle, and you can see it is the alternate interior angle. And the last and not the least is like this way. The addition of this angle and this angle would always be 180 degree. So if one of the angle is alpha and this other angle is beta, then the sum of alpha and beta would be equals to 180 degree always. So now let us utilize the same things over here. So the first pair of parallel line is AB parallel to QR, and the transversal cutting this two is the line segment AC. We can see Here is the first parallel line, here is the second parallel line, and this is the transversal cutting them both. Or we can say a line segment that is meeting both of these parallel lines, okay? So now let us utilize the property of the corresponding angle. So according to the corresponding angle, if this angle has a value alpha, then this angle would have a value alpha. I am talking about the angle BAC. This would be equals to the angle RQC. You can look in the diagram and let it be equals to a variable alpha. As you can see, I have marked in the diagram. Now similarly, let us talk about the other pair. So the other pair of parallel line is BC parallel to PQ, and the transversal, that is the line joining this both, is ultimately the line segment AC again. So these two lines are parallel and here is the transversal. So again we are going to use the property of the corresponding angles. So if I take this angle as equals to theta, then this angle would have a value theta. So the angle AQP is equals to the angle ACB, and I have taken it as a variable theta, okay? These two things we got because of the parallel lines and the property of corresponding angles. Now let me just write these things clearly and we will move forward in the solution. Okay, so here I have written the things in a bit more clear manner. Now let us move on to the solution. So first of all, what we did till now is we have utilized all the things that we can have from the parallelogram. Now let us talk about the most important shape present in this diagram, and that is this particular circle. So it was a given data, that is the point Q is the point where the line segment AC is tangent to the circle. So as it is given at the point Q, the line segment AC is tangent to the circle. This means if this point is the center, let the center of the circle be marked as the point O. So if this yellow point is the center of the circle and that we have taken as O, and now if I will simply draw the radius from the center of the circle to the tangent point, the angle formed over there would be 90 degree, and this is because of the theorem, that is the angle formed at the point of contact of the radius and the tangent line is always 90 degree. Okay, now there was one more thing that was clearly mentioned, and it was the point P, the point Q and the point R, that are ultimately the corner of the parallelogram, lies on the circumference of the circle. So if this point P and the point R lies on the circumference of the circle, so if I will simply draw a line segment from the point O to P, it would ultimately form the radius of the circle, because a line segment from the center to the circumference is the radius of a circle. Now look carefully, the angle between this pink line, that is the radius, and the tangent line is 90 degree. Now we have some part of this angle as equals to theta, that is between these two lines. Therefore the remaining angle that is going to be from this line to this line would simply be greater angle minus the smaller angle. The greater angle is 90 degree, the smaller angle is theta. Therefore this remaining angle would have a value 90 minus theta. Now recall that we have got the length of OP as the radius of the circle. So this length would be the radius, and again OQ is also the radius of the circle. So here we have formed an isosceles triangle. So if these two sides are equal, these base two angles would have the same value. One of the base angle is already having a value 90 minus theta. Therefore the value of this other angle would be 90 minus theta again. Now in this triangle we have got the value of two of the angles. So if we will simply apply the angle sum property, the value of this third angle would simply come out to be 2 times theta. Now to move forward in the solution, we have to utilize a geometrical theorem related to the circles, and it is like this way. If we have a circle, then the angle subtended by the chord at the center is double the angle subtended by the same chord at the circumference and in the same segment. So in simple words, if AB is my common chord and it is subtending an angle beta at the circumference, then the same chord AB will subtend an angle 2 times beta at the center of the circle. And the thing to be noted is that both of these things should be in the same segment, that is the upper part of the chord or the down part of the chord, wherever it is. So now let us utilize the same theorem in our solution. So the first thing that we should do is we have to recognize the common chord. So inside this diagram we can clearly say that we are going to take the common chord as PQ. And the reason we are taking PQ as the common chord is because it is already subtending an angle POQ at the center and it is having a value 2 times theta. Now what about the angle subtended by this chord at the circumference? So for that we have to draw an additional line segment, and it will be simply the diagonal of this parallelogram running from the point P to the point R. Now recall that it was already given the point R lies on the circumference of the circle. This means the chord PQ is subtending an angle PRQ at the circumference. Okay. Now as per the theorem, the angle subtended by the chord at the center is double the angle subtended by the same chord at the circumference, and also they should be in the same segment. So here we can see that both of these angles are in the same segment, and the angle subtended by the chord at the center is 2 times theta. Hence, the angle subtended by the same chord at the circumference would have a value 2 times theta upon 2, and it would simply be theta. Okay. Now let me just remove these things and also these things from this diagram. Now we can clearly see that we have got the value of the angle PRQ as equals to theta. Now I'm just going to remove the marking of this angle from the diagram because we need to mark some more angles at the same spot, so there is no confusion, okay? And once that thing is done, we will just bring it back. That is the reason I wrote this thing, that is the value of the angle PRQ is equals to theta. Now what I will do is I will simply draw a line segment from the point O to R. Now as it was given, the point R lies on the circumference of the circle. This means the line segment OR ultimately becomes the radius of the circle, and the line segment OQ is already the radius of the circle. Okay. Now look carefully, this complete angle is 90 degrees. Some part of this angle is equals to alpha. Therefore the remaining angle, that is from here to here, would have a value greater angle minus the smaller angle, therefore 90 minus alpha. Now as this triangle is an isosceles triangle, the value of the base angles would be equal. One of the base angle is already having the value 90 minus alpha. Therefore, the value of this other angle would also be 90 minus alpha. Now in a triangle, we have already got the value of two of the angles. Therefore, by applying the angle sum property, the value of this third angle would simply turn out to be 2 times alpha. Now we are going to utilize the same theorem that we did in order to get the value of the angle PRQ as equals to theta. So again, we will draw the line segment from the point P to R. And as it was given, the point P lies on the circumference of the circle. This means the chord QR is subtending an angle RPQ at the circumference, and the same chord is subtending an angle 2 times alpha at the center, and both of these angles are in the same segment. So according to the theorem, the angle subtended by this chord at the center would be double the angle subtended by this at the circumference. So at the center it is subtending an angle 2 times alpha. Therefore the angle subtended by the same chord at the circumference would be 2 times alpha upon 2, and that would simply be equals to alpha. So now we have got the value of the angle RPQ as equals to alpha. So now I'm just going to remove all these things from the diagram, and I will just mark these two angles that I have written in white at the bottom. So from P to R we have to draw a line first of all, and now we have the value of the angle PRQ as equals to theta and the value of the angle RPQ as equals to alpha, and we are able to mark these two angles as theta and alpha is only because of the presence of the circle. Okay. Now I'm just going to remove this thing, and also I'm going to mark some of the lengths in this diagram. Now recall that we have already taken the length of PB as equals to x and the length of PR as equals to y. And as it was given, this quadrilateral is a parallelogram, opposite sides would have the same length. So if this length is equals to x, the length of QR would also be equals to x, and also the length of PQ would be equals to y. Okay, so here we have finished the markings of all the required angles and the line segments. Now let us utilize the fact that we have some of the areas of the figure given. That is, the area of the parallelogram is 4 meters square and the area of the triangle QRC is 1 meter square. So the triangle QRC is ultimately this purple triangle, and it is having an area 1 meter square, and the area of this complete parallelogram is 4 meters square. Now we know this thing about the parallelogram, and that is, in a parallelogram the diagonal divides the parallelogram into equal area. So if the area of this complete parallelogram is capital A, then area of this each of the triangle would simply be A upon 2. So the same thing is happening over here. Because of the diagonal PR, the parallelogram is divided into two triangles, and both of these triangles should have an area, the complete area of the parallelogram, upon 2. Now it is already given the area of the parallelogram is 4 meters square, hence area of each of these triangle would be 2 meters square. This means area of the triangle PQR is equals to 2 meters square, and also the area of the triangle PRP is equals to 2 meters square. Both of these triangles have an area 2 meters square. Okay. Now look carefully, we have some pairs of the triangles in which two of the angles are equal, hence we can make them similar by the property of angle, angle, angle. So the first pair of similar triangle is like this way. We have the triangle PQR similar to the triangle QRC. We can see that in the triangle PQR, first of all look carefully, the triangle PQR is this one and the triangle QRC is the purple color triangle. In the triangle PQR, the value of angle P is alpha, the value of the angle R is theta. Now in the triangle QRC, the value of the angle Q is alpha and the value of the angle C is equals to theta. And ultimately if we apply the angle sum property, the value of the third angle would also be equal. So we have written down these two triangles similar to each other, And the property because of which these two triangles are similar is angle, angle, angle. And also I have written this thing according to the correspondence, that is the first angle equals to the first one, the second one with the second, and the third one with the third one. And the reason we have to write it according to the correspondence is because when we write it according to the correspondence, we can take the ratio of their sides correctly. So as this thing is already according to the correspondence, the ratio of the sides would come like this way. PQ upon QR, this ratio would be equals to QR upon RC, and this ratio would be equals to PR upon QC. Now out of these three ratios, some of the ratio is already having some kind of lengths that we have already taken as variables. For example, the length of QR is equals to X and the length of RC is nothing. So this ratio would not be helpful. The length of PR we have not marked in the diagram, and the length of QC also we have not marked. So this ratio would also be not helpful. Now just remaining with this ratio. So according to the particular diagram, the length of PQ is equals to Y and the length of QR is equals to X. So this particular ratio is ultimately equals to Y upon X. Now let us utilize the concept that we have just seen. If two triangles are similar, the ratio of their areas. So area of the triangle PQR is ultimately half the area of the parallelogram because it is that particular triangle. So area of the complete parallelogram was 4, hence the area of the triangle PQR is equals to 2. So 2 upon area of the second triangle. And the second triangle is this particular purple triangle that is already having a value 1 meter square. So 2 upon 1, this thing equals to square of the ratio of their side. So the ratio of their side is Y upon X. So Y upon X the complete square. And let this be question number 1. Okay. And this we have got because the triangle PQR is similar to the triangle QRC because of the property of angle, angle, angle. Or we can just say angle, angle. It's all okay. Now let us talk about the second pair of similar triangle. So I'm just going to keep the triangle PQR as it is, and we are just going to make a pair of this triangle with some other triangle this time. So this time we are going to make a pair of the triangle PQR with the triangle APQ. And these two triangles are again similar by angle, angle, angle. You are already familiar with the triangle PQR that is over here. Now the other triangle that we have taken is the particular red triangle on the top. So now look carefully. The angle P in the triangle PQR is having a value alpha, and the angle A in the triangle APQ is having a value alpha. The angle R in the triangle PQR is having a value theta, and the angle Q in the triangle APQ is having a value theta. These two triangles are similar by angle, 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 and I have already named this triangle according to the correspondence. So if I will take the ratio of their sides, it will come out to be like this way. PQ upon AP is equals to QR upon PQ, and this thing equals to PR upon AQ. On the top we have the blue triangle, and at the bottom we have the red triangle. Now out of this ratio we have to take the perfect one. So we can see that in the red triangle, the side length PQ is the only side whose length we have taken as variable. And in this particular ratio, and especially in the denominator because that denotes the sides of the red triangle, only in the middle ratio we have the denominator as PQ. And in the numerator we have the length QR, and it is also having a length X. Therefore the middle ratio can also be written as X upon Y. And the square of this ratio would be equals to the ratio of their areas. Now look carefully, in the numerator we have taken the length X, that is the length QR, and that is the length from the triangle PQR. So in the numerator we have to take the area of that triangle, so that is having a value 2 upon area of the red triangle that we don't know, and that is also the thing that we have to find. So let it be equals to a variable capital A. So now we have got the second equation, and that is representing X upon Y the complete square is equals to 2 upon A. And if I just reciprocal this equation, I will get the thing as Y upon X the complete square equals to A upon 2. Now look carefully from the second equation and in this first equation, we can see that Y upon X the complete square has a value 2 upon 1, and again the value of Y upon X the complete square is equals to A upon 2. Hence we can compare these two equations, and the comparison will give us A upon 2 is equals to 2 upon 1, and by doing the cross multiplication the value of A will turn out to be 2 times 2, that is equals to 4, and as all these areas were in meter, therefore the value of A would be 4 meters square, and the variable A is ultimately representing the area of the triangle APQ, and this is the thing that we are looking for. This was my way to solve this particular problem. If you have any other method other than this, or else if you have any other question that you think I should try, you can do comment below, and if you want to share any kind of picture you can email me, or else you can send it to me on my Instagram. The link is in the description.